Thank you very much. Yes. So let me share my screen and yeah, is my screen visible?
It is.
Yeah, sure. Thank you. So my name is, first of all, thank you very much for taking the time. I know that it's a very busy time at WESI, especially after their new project on the hydrogen one. And beginning with our project, my name is Abdullah Khan, and I'm a student at Memorial University of Newfoundland, master's student. And this project is my thesis project, as well as I'm working on as part of the Ocean Idea Challenge by Ocean Startup project. So for which I got a funding, and I'm currently in my customer discovery process. So our idea was to convert the dissolved CO2, which is in seawater, into green methanol and also hydrogen, and use it as a low carbon fuel, which could be an alternative for marine shipping, and also an alternative for feedstocks, and also an alternative for cars being used to use methanol as a fuel. These are just our goals and objectives which from this project. So moving on to the decarbonization challenge. So as we know that the maritime sector is facing regulatory challenges in order to adopt low carbon fuels. And also the global methanol production is exceeding 100 million tons annually. So it means that there is a demand of methanol. And the current infrastructure of carbon infrastructure, they remain so energy intensive, and they are quite expensive, and because of their low atmospheric CO2 concentrations, and being utilizing other sources of energy. So we came up with this idea on utilizing sunlight, in a photocatalytic reactor. So just a moment. Yeah. So as we know that here we have the photocatalyst, which I have synthesized in the lab. And this photocatalyst is made up of two materials, semiconductor materials. So they are light active. So when light falls on them, these semiconductor materials, or there is a whole chemistry going on where there is a jump of electrons, and this leads to the production of methanol, so CO2. So once the sunlight is incident on the photocatalyst actually breaks up the water molecules, H2O, into hydrogen and oxygen. And this is known as the water splitting reaction. And this hydrogen then takes part in the conversion of CO2 into methanol. So when we have CO2 and it gets react with 6 hydrogen electrons, we get the product methanol. So this is the part which I am currently working on. And in the future, we also look to integrate with electrolysis. So in that case, we could even use the hydrogen also as a fuel. The reason here we target methanol is because it's it's a liquid fuel as compared to the hydrogen. This is the photocatalyst which we have designed, and the whole mechanism behind the photocatalyst. So this photocatalyst is easy to design using very simple solvothermal method. We also use solvents. Yeah, so those solvents are mentioned here, such as the TEOA, triethanolamine and acetonitrile, in order to increase the concentration of CO2 in the water, or in the or if we are using seawater, it already has a concentration of CO2. And our target product is the green methanol, which could be used as marine fuels and industrial fuels, and also as chemical feedstocks. So this is the product which we are getting from our conversion. And we have the green hydrogen. So as we know that the water splitting reaction, it's a continuous process. It takes on and then leads to the production of methanol. We could even use that green hydrogen as a product, and we could even eligible for the carbon credits trading. So this is the global market opportunity for methanol. And Maersk in Denmark, so it has ordered like 200 methanol fired vessels. So it shows that there is a demand or to decarbonize the shipping industry by using methanol fired vessels instead of the current ammonia or LNG fired vessels. And also having the green premium pricing. That's all what I would like to say. And also, so here is the, so this is the reaction which actually takes place. So as we know, this is the water splitting. This is not the water splitting, but this is the formation of the hydrogen molecules. And we have the, so as we can see, for the production of methanol, we require 6 hydrogen and 6 electrons in order to, for the conversion to take place. And there are various byproducts also in this method, such as ethanol and also a small amount of formaldehyde, but which is an intermediate product and it gets converted into methanol. Currently, I'm also focusing on some of the gaseous products which might be released, such as methane or carbon monoxide. And my target is actually to optimize the process as much as possible to lead to the production, to increase the yield of the methanol. And coming on, this is the, so this is the validation summary plan which we prepare from this or on the amount and all, yeah. Yeah, all those things which are required in order to scale up the process. And that's all from our side. And yeah,
Okay, so appreciate the presentation.
thank you.
I have a couple
Thank you.
questions.
Yeah, sure.
And I guess, first will be what are you seeking from me specifically? Is it feedback on your concept? Are you looking for industry partners? Are you looking for potential customers? I guess maybe that would be my first question.
Yeah, sure. So at this present stage, we are looking for feedback in order to complete the customer discovery program. So we even went to Halifax and in the H2O conference, and we also got connected with various people. So in order to find the right people to take the feedback. So from one of the person from Department of Energy, we got to know that Waterford could be a best one. And also we were in the Green Roots program for the open house, and there we got to know about the hydrogen project. So made me that made me that attracted me to take this interview. So we are looking for more likely for feedback at this stage. Yeah.
Okay. So if I could you go to slide 5?
Yeah, sure.
Okay. So a couple comments. Is the intended location for this to operate at sea or simply use seawater as a source while the infrastructure is on land?
Mm, yes. So this infrastructure is more like a reactor. So it could be, we use the seawater, so it won't be on the seawater, but
Okay.
it would be somewhat near the seawater or in the coastal region so that it's easy to extract and do the processing.
Yeah. Okay. Um, so electrolysis with seawater is presents some challenges
Yeah,
versus desalinated water,
right.
which I'm
Yeah.
sure you're familiar with.
Mm,
Um, Typically, it degrades equipment
yes,
quite
that's right.
quickly.
Because of the anode and the cathode reaction. Yeah.
Yeah. Um, as you know, like we have a hydrogen project.
Yeah, right.
A big concern with electrolysis is purifying water. Now there is electrolysis with salt water, seawater, but
Mhm.
they're to anybody in the hydrogen electrolysis business, I would I would address those concerns about seawater electrolysis right away. As even for me right now on this concept, I'm thinking like, okay, well, it's quite difficult. I would love to see as a part of this an estimate on just how much methanol and hydrogen you expect to produce per whatever megawatt of of
Yeah,
electricity used,
right.
um, that's going to lead to some sort of cost benefit
Yes.
analysis.
Yeah, so you mean
Um,
like scaling up the process in order to understand it on a technical level. So like how much amount on a pilot scale on how much amount of CO2 would be required for production of 1 kilogram of methanol?
Not so much how much CO2.
Yeah,
Um, let's just say so a 1 megawatt electrolyzer probably makes about 400 kilograms of hydrogen per day.
right.
Um, with that, with the solar system, the storage and distribution system here, that's we're talking now in the tens of millions of dollars
Right.
for infrastructure.
Hmm.
Um, so I think it would be worthwhile to present what that looks like. Um, like we need this much generation capacity of solar panels connected to this size of electrolyzer. We're going to use this many cubic meters of salt water,
Yeah,
and that'll give us a production rate of this much hydrogen per day or per hour. Um, and then we'll be able to remove this much CO2 from the ocean and create this much methanol.
right. Yeah.
I understand this is a very conceptual project, but each piece of this represents something incredibly complex that, an engineering team would spend quite a bit of time on in order to perfect.
Yeah, for me, for us, we are currently actually focusing on the photocatalytic part. So the
Mhm.
reason behind it is it's not energy intensive. So it just requires the sunlight and the photocatalyst alone. So
Mhm.
that actually holds a benefit to the process, but only reason is that it is at very low TRL level. So they have the same mechanism as electrolysis and the photocatalysis, but electrolysis is more efficient process and it's more quick as compared to the photocatalytic process. Although the mechanism remains the same, the water splitting and etc.
Okay,
Mm.
understood. I appreciate that.
Mm.
Um,
Thank you very much for your interesting insight.
yeah,
Yeah,
I mean, in that case, if that's what you're focused on, you could just buy hydrogen, right?
right.
I know it wouldn't be green hydrogen, but the things behind that left line,
Yeah,
solar to electrolysis to hydrogen, like that's a complex project in itself.
right.
Um, how is methanol typically stored and transported?
Yes, so methanol being a liquid fuel, it could be transported in the tanks which we have. Only safety factor which is concerning regarding methanol is its combustion. So as we know that the methanol causes combustion or methanol combust without giving a visible flame. So it is flammable without giving any sign of it in the daylight. So this is what I learned from previous interview just today. So they explained me that it's flammable, so and invisibly flammable, so you cannot detect it. But comparing it to transportation of gas, it's easier as compared to.
Mhm. Can I see the next slide, slide number
Yeah,
6?
sure. Mm, there we.
And is this theoretical, or have you tested this, on a smaller scale? Is this a technology that
Uh,
exists?
Yes, so I tested it in the lab. So we designed the photocatalyst and we did the conversion using 50 mg, 50 milligram of this photocatalyst, and we used like pure CO2 and dissolve it into the water using triethanol amine. And then we did the conversion. We used visible light. So we had a UV light machine which we converted into visible light using a filter, and then we ran the reactor. So we did this in our lab.
Okay.
Yeah.
Okay. Interesting.
Thank you.
Yeah. Uh, I mean, um, I think that's important to include. I would include that in your presentation here. You know, that this is lab tested.
Yeah.
Um, Maybe some conceptual idea of what that might look like at scale,
Mhm.
um,
Yeah.
in order to, bring this into some sort of like scale production that you could test outside of the lab.
Yeah. Right.
Yeah. Um, yeah, it's certainly an interesting concept.
Yeah.
Um, I understand it, in order for it to be a green or renewable fuel, you need source of green hydrogen. That's correct, right?
That's
And
that's right.
actually, I would say the green hydrogen, yes. So it's produced by the water splitting. So the this photocatalyst itself breaks up the water molecule into hydrogen and oxygen. And that's how the reaction goes on. So the CO2 molecule is in the water, and this photocatalyst breaks up the water molecule into H2 and oxygen, hydrogen and oxygen. That hydrogen takes part in the conversion of CO2 into methanol. So it's not like getting a different source of hydrogen.
Okay, so
Yeah.
maybe I'm misunderstanding. The photocatalyst process
Yeah.
also produces hydrogen,
That's
Yes, that's right.
and you also need hydrogen through electrolysis.
uh, in order to in order to improve the efficiency of the process. We do not necessarily need electrolysis process, but in order to increase the efficiency of the process, in order so that the process, so as we know that we require like 6 hydrogens, so it's quite difficult to in order to increase the efficiency. So the idea was to actually use another source of hydrogen so that more and more CO2 could be converted. But photocatalytic process in itself produces hydrogen.
Hmm. So can you give me an idea of how the rate of hydrogen or methanol production, is it based on the, I guess, area of volume of photocatalyst, or something that is
Yes.
catching sunlight? So
Y-
say like per square meter of sunlight. I guess I'm trying to connect this here to something tangible.
Yes. So, in order to explain that, I can show the picture of the reactor which we have in the lab, and that would actually help us to visualize more. So, at present level, we have this exact same photocatalytic reactor in our lab, which is actually filled with only 50 ml of water, and and we have like 50 milligram of photocatalyst which we have designed, and then we pass the CO2 gas through one of the ports, and we ensure that it's trapped one and it's there is no leak of gas. And then upon this up the source of light, we have the light source which actually concentrates the light on the powdered photocatalyst and also on the CO2. And this is where the reaction actually takes place. So it's more on ppm level at present. So
You
for
know?
example, the reaction which we have done, it produced methanol of something like 35 to 40 ppm.
Okay, so it produced 35 or 40 ppm.
Of methanol.
Um, yeah, so and you started with 50 milliliters of water. Is that
Yes,
right?
right.
Yeah.
And 50
Uh,
milligram of photocatalyst. Milligram.
okay.
Yeah.
And then how much, so what would be the volume of methanol produced in grams or milliliters?
In grams or milliliter, it's quite difficult to quantify in that value because ppm is at a very low scale,
Yeah.
to be
Yeah,
honest.
I understand these are
Yeah,
on scale. So basically, like I think that for your purpose here, you should come up with a easily relatable
right.
uh, some sort of metric of
Yes.
measurement, right? And I don't know what that would be, but maybe like per every cube of water, you produce X amount of
Yeah.
methanol. And then because what you're suggesting this technology is going to be used for is at a gigantic scale, right?
Right.
Huge. Something that's going to cover football field size of area to capture sunlight for industrial purposes,
Right.
and um, that that needs to be understood. I want to understand if it's feasible, but if there are other complications that come with it, right? What does this photocatalytic reactor look like? Are you deploying thousands of these exact ones, or is there something that
Uh,
is larger that can do the same thing to a larger volume of
yeah.
seawater to produce methanol at the same
So
time?
yeah, this photocatalytic reactor are not more like so complicated. There are research studies which actually just use quartz reactor. So those are like simple pieces of glass could also be used, but we prefer using this reactor so that the CO2 gas does not escape. So we have to collect our gas samples also and the liquid samples. I think, yeah. So it's there is one more of this one. So this is actually for the photocatalytic. So it has like two sample ports. So in order to make ease for the collection of the samples, so the part we collect the gas samples in the liquid samples, that is why we have such a complicated structure. But it could be in a very simple way also, such as using a simple piece of glass. So we just need a thing to hold up the water and in order to have the photocatalyst in it.
Well, guys, I've kind of run out of questions that I could ask.
Yeah.
I work in the green energy industry. We have a hydrogen project. I work predominantly in
Yeah.
offshore wind. Hence the turbine here in the background somewhere.
Oh, yeah.
But yeah, I appreciate your time and the effort that you put in this. I think it's important you reach out, talk to people in the industry for sure. Although the these are very very deep process engineering and chemical engineering concepts
Um,
that you're suggesting. So your best feedback is likely going to be at people connected to those. Um, yeah, try and include information
yeah.
about processes and scale in your presentation that are going to be, relatable to industry. Not necessarily about the exact application. You don't need to solve all those problems right away, but you
Mm.
need to show a business case, right?
Yeah, right. That's
There
right.
are
Yeah. So,
there's a there's 1,000 different ways to create um, fuels using green energy and different types of um, uh, ways to
yeah.
combat carbon emissions. But a lot of them, most of them, are typically really inefficient
Yes.
and have no pathway to commercial viability with um, today's current technology.
Yes, that's
So
right.
yeah. Okay. So yeah, thanks so much.
Yeah.
If you want to, if you're working on this for whatever in 6 months, if you want to call me up again and say, hey, Nick, you know, take a look at this, would happy to do so. Yeah, appreciate your time.
Yeah, that's
Thank you, Nick, for the meeting. We would also like that if you could connect us with some prospective leads like you who would be willing to do the customer discovery. That would be really great help for us.
Yeah, I will. I'll think about that. Best thing you can do is email my work email,
yeah.
nick.house@wesi.ca, and I can kind of go through my Rolodex figuratively and think about some folks who would like to hear what you're talking about.
Yeah,
Okay?
that's great. Thank you so much for your insights, and it was great meeting, and also to understand about the hydrogen. So hydrogen production also. So yeah, it's a great one from our insights too, because it's all related to the hydrogen. So that plays an intermediate role. Without having the hydrogen, methanol cannot be produced. So whole of the dynamics actually passes through the hydrogen, and then it moves on to the methanol. And it's great to chat with you, and also to have your insights. And we make sure that we have these insights in our updated pitch decks also, and we move on further with this. And that was great.
Okay, awesome.
Thank you so
Thanks so
much.
much.
Have a
Thank you
nice
so much.
day.
Have a good day.
Bye.
Bye. कितने बार इट्स ग्रेट बोलेंगे? इट्स ग्रेट, इट्स ग्रेट, एक ही बात को रीइटरेट क्यों करते हैं आप?
यार ये ऐसा इसका मुंह क्यों बना था?
अरे भाई, इसका मुंह ही ऐसा है। इसका
What do
मुंह
you
बना
think?
नहीं था, इसका मुंह ही ऐसा है।
What do you think?
हम्म?
What was the impact?
I don't think so impact बुरा था because he said that just email me and I'll see the folks who are interested in this and I'll let you know about them. I mean, he was like a normal person and it looks like he has a tiring day and because that his मुंह वाला बना हुआ है।
Right. यार
क्योंकि
ग्रेट
सुबह
ग्रेट।
से वो काम ही कर रहा होगा ना, 4 बज गए, तो ज़ाहिर है। और आप ही एक ही चीज़ को रिइटरेट, थैंक यू फॉर योर इनसाइट, थैंक यू फॉर योर टाइम,
और क्या
अगेन थैंक
करेंगे
यू फॉर
यार?
5 बार इनसाइट टाइम।
यही करना होता है।
हाँ, तो ठीक है, चलें।
अबे यार मैंने रिकॉर्डिंग ये रिकॉर्डिंग अपलोड नहीं करूँ।